Assalamualaikum. We from Group 4 will present the second case study for the subject of business intelligence entitled Customer Churn Prediction Telecommunication Company. My group members consist of myself, Putri Shazlana 079174 and Nur Ifahani 079213 and Elia Rashida 076878. For the introduction, customer churn has been a significant problem in the telecommunication industry, where intense competition and identical product services render it easy for customers to switch providers. It is cheaper to keep current customers than to gain new ones, which makes customer retention a business priority for businesses that want long-term profitability. Predictive modeling and classificatory techniques allow businesses to achieve customer behavior, thereby allowing them to gain the most critical churn patterns and take preventive action. This project includes forecasting customer churn using business intelligence application to enable the company to make decisions based on facts and improve the customer retention strategy.
Dataset description. Let me begin with an overview of the dataset used in this study. This customer churn dataset was sourced from Kaggle, has 5,000 samples and 21 columns. The goal is to predict whether a customer will churn based on the target variable churn, which is labeled as yes or no. The dataset includes a mix of categorical, numerical, and mixed-type features. A few sample variables include gender, which is categorical with value like male or female, tenure, which show how long a customer's history, contract, which describe the type of service agreement, monthly charge, which is a float value, and churn, the target variable we aim to predict. This dataset was selected because it offers rich customer behavior data, a variety of feature types, and is ideal for a classification model in real-world business scenarios.
For the problem identification, first, the company lacks the ability to predict customer churn because of not enough utilization of existing customer information, resulting in premature identification of churn risk. Second, unless the major drivers of churn are known, the company struggles to write effective retention strategy, causing substantial revenue loss and increased customer acquisition costs. For objective, we have three. First, identify key determinants of customer churns. Third, to forecast churn behavior. Develop a categorization model. Third, offer insight and guidance to assist in lowering churn and enhance customer retention practices.
Next, dataset handling and pre-processing. We started with a dataset containing 5,000 rows and 21 columns. During the initial inspection, we found issues such as incorrect data types and missing value. For example, the total charge column had empty string that were not recognized as missing value. We addressed this by recovering the column to numeric and grouping rows with invalid entries. We also convert the target variable churn from yes and no to binary value 1 and 0. After pre-processing, the dataset had 4,992 clean and mostly numeric rows, ready for analysis and modeling.
Data mining technique. For this case study, we decided to choose classification model. One of the algorithm is logistic regression. This figure shows the first step, loading the dataset cleaned Telco.CSV using Python. It displays the first 5 rows of customer data to confirm the data has loaded correctly. These include columns like gender, senior citizen, tenure, and internet service. It helps check the structure and values before starting analysis. This figure displays the structure of the dataset using DF info and shows that several columns like gender, contract, and payment method are in text format. These need to be converted to numbers using label encoding so that model can understand them. Machine learning algorithms work only with numbers, not text. These figures show how the data is split into training and testing set, 70 and 30 ratio, and how standard scaler is used to normalize the futures. Then a logistic regression model is trained using this processed data. Splitting ensures the model can be tested fairly, and scaling improves model performance. This figure presents the model performance after training. It shows accuracy at 0.04%, precision and recall high for non-churn class and lower for churn class. Confusion matrix confirms more churn customers are misclassified. A heat map of the confusion matrix is used to visualize true or false prediction. The model correctly predicts 968 customers who stayed and 264 who left. However, it wrongly predicted 115 as churn and missed 181 real churns. Clearly shows the imbalance. Model is better at predicting customers who won't churn. This figure ranks the most important features influencing churn based on the model coefficients. First, tenure. Customers who have been around for a long time tend to stay. Secondly, monthly charge. High monthly fees increase the likelihood of churn. Thirdly, contract type. Long-term contracts such as 2-year reduce the risk of churn. It may help the company know which factor affect customer retention the most.
The second classification model used in this study is the random forest classifier. It is well suited for binary classification problems and can handle both numerical and categorical data effectively. We begin by importing the clean dataset and the necessary libraries for model training and evaluation. A quick preview confirms that the data was ready for processing. We remove the customer ID column and separate the target variable chain. Then we apply one-hot encoding to convert categorical features into numeric format. The dataset was split into training and testing set using 80 and 20 ratio. We then train a random forest classifier with 100 decision trees. This sample method improves accuracy by combining the result of multiple decision trees. The model achieved an accuracy of 78.8% with a precision 63 and a recall of 40. We visualize the result using a confusion matrix which confirms the model strength in predicting non-churn cases.
For the data maintaining, I was responsible for applying the naive-Bayes classifier, a simple yet powerful probabilistic algorithm based on Bayes' theorem. We choose this model because it is efficient for binary classification tasks like churn prediction and performs well even with relatively small datasets. After cleaning and encoding the dataset, we split the data into training and also testing set. Then we use feature scaling to normalize the data and train the model using the Gaussian naive-Bayes algorithm. Now, for the model evaluation, we test 3 classification algorithms: logistic regression, random forest, and naive-Bayes. Based on the result, in table 2, logistic regression achieved the highest overall accuracy of 18.04%, making it the most relevant in terms of general prediction. However, naive-Bayes stood out with the highest recall score of 75% for detecting churns, which is important when the goal is to identify customers who are likely to leave. Meanwhile, random forests show moderate performance across all metrics, offering a balance between precision and recall. Though it was slightly less effective in identifying actual churners, these results show that each model has its own strength, and the best choice depends on whether the business prioritizes overall accuracy or sensitive to churn detection.
We create a Power BI dashboard to visualize churn patterns. Okay, first, the pie chart shows that 26.3% of customer churn while 73.7% stay. Second, the line chart reveals that most churn happen within the first 5 months. Third, the bar chart shows that electronic check is the most used payment method and is linked to higher churn. Fourth, the column chart highlights the fiber optic users churn more than DSL or no service user. Next, the donut chart shows that fiber optic users also pay more monthly, which may contribute to churn. And last, the stack bar chart compares churn between customers who use paperless billing.
Next, based on the BI dashboard, we developed using Power BI. We found key trends among churned customers. Most churn occurred within the first 5 months of tenure, especially among users of fiber optic services. Customers who use electronic checks and paperless billing also showed higher churn rates. This suggests that targeted actions such as improving service quality, offering early incentives, and promoting more reliable payment methods could help reduce the churn. In conclusion, this case study has shown that integrating predictive classification models with business intelligence dashboards offer a powerful solution for analyzing and responding to customer churn. Through this approach, we will be able to detect churn patterns, understand customer behavior, and provide insights that support strategic business decision. The use of both data mining techniques and visual analytics helps businesses act more proactively in retaining customers. Looking ahead, future improvement could focus on enhancing model performance through hyper parameter tuning and resolving data balance using resampling methods to improve prediction accuracy and reliability even further. That's all from our group about this case study, and thank you for listening to our presentation video.